my parent function? Parabola. So I would say a minimum of 3 exact points. So 0, 0, 1, 1, 2, 4, negative 2, 4, negative 1, 1. We could even do like 9, 3, or sorry, 3, 9, and negative 3, 9 if you wanted. So I will be checking that. I want it dashed. Now you should be able to tell me what your transformation is. What will this minus 5 do to my graph? What does d times 2 do? So outside is y does what you think. If I take my height times 2, I'm going to become taller. So it is stretching. It's going to get bigger. Okay. The stretching and shrinking, if I'm not wrong, that is the thing we are having trouble with, correct? What strategy did I give you for helping with that? Write the ordered pairs out. So this portion is not required, but it will help you if you are struggling with the stretching and shrinking. So if I'm looking at this, am I changing my x or my y? Outside is y. It does what we think. So it has times 2, so I'm taking my y's times 2. So this becomes negative 2, 8. Negative 1, 2. 0, 0. 1, 2. And 2, 8. Does everyone know where I got that list of ordered pairs? So it takes a little bit of time, but it's only on the stretching and shrinking ones, so it's worth it. Now we just need to plot those points. So negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 8. And then sketch your parabola. Questions on that? Oh yeah, I'm not done.
Does it matter if you shrink or stretch first, or do the
No, the left and right and stretching and shrinking doesn't matter. So, those are my points for just the stretching. I do have people that like to draw that intermediate graph and then move everything to the right. And so they actually have an extra graph on theirs. That's okay. If you want to do that, then you have to go back and either erase it or grab a highlighter and highlight your final answer if you want to draw that little piece. You don't have to. The other option, if you graph this, or if you don't want to graph that little intermediate piece, just take your new points, so like negative 2, 8, and then move it right 5 before you put your dot. So negative 1, 2, and then move it right 5. 0, 0, move it right 5. Take your 1, 2 and go right 5, and your 2, 8. Go right 5. Could you tell me the domain of that? Negative infinity, positive infinity. What would your range be? Bracket 0, comma, infinity. If I asked you where is that graph increasing? Bracket 5 to infinity, if we're going off the final one. Where is it decreasing? If I asked about the final one. Okay, let's look at problem 2. So this one put a 3 on the x and a plus 4. What would the plus 4 do to my graph? up 4. The 3 on the inside is horizontal and does the opposite. So it would be like dividing my x's by 3, so they will shrink. Okay. Absolute value is my parent function, so that's your v. Absolute value of 0 is 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. So you could graph that. That's your v. Okay. If you need to, write out some points. What's changing on these? My x or my y? My x. And x does the opposite. So I am not taking my x's times 3, I am dividing them by 3. So it's negative 2/3, 2. Negative 1/3, 1. 0, 0. 1/3, 1. 2/3, 2. So I went through those ordered pairs, divided every x by 3. So, if I want to graph this, a little tricky here. So I'm at negative 2/3, 2, and then what else do I need to do to my graph? Up 4. So you go to negative 2/3, 2, and then move that up 4. Negative 1/3, 1, up 4. 0, 0, up 4. 1/3, 1, up 4. 2/3, 2, up 4. So what we're getting is this very skinny absolute value graph that's been moved up. I'm going to give you guys a couple minutes, and I would like for you guys to try the next 2. Okay, so give them a shot, and then we'll come back and talk about them together. We should get our parent function. How do I know the parent function when I look at the problem? What am I looking at to identify the parent function? Yeah, I'm looking for like a cube root, a square, a cube. I'm looking at those exponents. This is a cube root, which is the sideways chair. So we have those points. What does this negative do? Flip it over the x. What's the plus 3 do? Okay, so if I take a point, 0, 0, and I flip it, it doesn't go anywhere, and then left 3. If I take 1, 1, and flip it over the x, it goes down here to negative 1, left 3. If I take negative 1, and flip it, it goes up here, left 3. And so what it's done, our graph looks like this. Now what if you're on the quiz and you're not sure? What could you do? Plug it in. You could go to the graphing calculator and just confirm. That's not going to tell you the exact points, but it'll tell you if you're on the right track. Could you even make a t-chart for this if you absolutely had to? Sure. So there are other ways to get there or to check yourself if you're unsure about something. Number 4, I have a square root. So my parent function is a square root. Looks like this. A negative on the x. So it makes all my x's negative. So we flip it over the y. And the minus 5 will move it down 5. So if I take this point, flip it over the y, it doesn't move. Down 5. If I take 1, 1, flip it over the y, it comes over here to negative 1, 1. Down 5. If I take 4, 2 and flip it over the y, it goes to negative 4, 2. And then down 5. Question 6. Yes, ma'am.
I did not look at that. Okay, so if I flip it on Y, I should see
You
down
flipped
here.
over to X.
Flip over to Y.
Other questions?
You flip first and then,
Just in general, always do up and down. That's kind of on
the way you just did it.
Yes.
You can flip it.
Yeah, I flipped and then did
But if you make that intermediate thing, you need to do
Then-
it first.
Yes. All right. We may or may not do all of these on the handout. We're just gonna kind of go through, but I definitely think we need to do some more practice with stretching and shrinking. So we're gonna try some more. This is the piece that's kind of new for us this year, so that is probably the hardest part here. What is my parent function? I see x cubed, so 0 cubed is 0, 1 cubed is 1. If you want, 2 cubed is 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8, so it looks like this. That's my chair. Okay, then, let's talk through. What's the minus 4 do?
Right 4.
What does this 1/2 do? Yeah, since it's smaller than 1, it shrinks. If you're not sure if it's stretching or shrinking, you could graph it and then tell me from the graph, did it get taller or did it get shorter? And you can get it that way as well. Okay, so our options, we can write out ordered pairs if we want. You know, I have -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. Am I changing x or y here? Well, I guess we're kind of changing both. The 1/2, is that applying to the x or the y? The 1/2 is applying to the y because it's out in front. So let's do that part first. If I take my y's times 1/2, and I get -2, -4, -1, -1/2, 0, 0, 1, 1/2, and 2. If I plot those, bless you. Now, that's not my final graph. If you need to plot all these, you can, or we've talked about just kind of doing everything at once. What else do I need to do to this to get my final graph? Okay, so if I take my -2, -4, right here, and then you can just move it right. -1, -1/2, right. 0, 0, right. 1, 1/2, right. 2, 4, right. So my graph looks like that. So when in doubt, take the time to write out those points. I want to do another one together, and then I'm going to have you guys try the last 2 on your own. What is my parent function? Parabola, x squared. 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. I need to do here? Okay, we're gonna go up 2. Horizontal, and inside does the opposite, so it will actually stretch. Inside, X, opposite, every time. So if I'm just gonna take care of that part, and say instead of taking my x's times 1/3, what am I doing to them? Dividing by 1/3. So 2 divided by 1/3 is 6. 1 divided by 1/3 is 3. 0 divided by 1/3 doesn't change. -1 divided by 1/3 is -3. And -2 divided by 1/3 is -6. These are not my final pieces. But if I take those, if I'm at 6/4, and then I need to also go up 2, then I just move that up 2. So then we had 3/1. And we are going to go up 2. If we have 0, 0, that's going to stay. We had -3, 1. Whoops, sorry. 0, 0. That stayed from the original, and then we had to go up 2. Failed to draw that little piece. We had -3, 1, then go up 2. -6, 4, and then go up 2. So what's happening is our parabola has gotten, it's been moved up and it's gotten really flattened out. Okay, we kind of took it and stretched it out, so it got really bad. Okay.
So every time it's horizontal, it's the opposite.
Yes, every time.
So if it was like 3, then it would be a shrink.
Yes.
Okay.
Yes, because it does the opposite. Okay, why don't you guys try the last 2? So this one will go up 3, and that's going to be the very last thing I do. This -1 would move my graph. And this negative would, like making my y negative, so flip over the end. So if I take a point, 0, 0, and I flip, it doesn't go anywhere. Then right 1, then up 3. If I take 1, 1 and flip, it goes down here, right 1, up 3. If you took 2, 2 and flipped, it would go down to -2, right 1, up 3. Way over here, if you flip, right 3. Should look like this. If your graph, a lot of you had something very, very similar, but your graph was down here. And what that meant is you moved it up before you flipped it. But if you think about order of operations, if I'm going to plug something in here, the very last thing I would do would be adding my 3 on the end. So we need to think about transformations in the same way as order of operations. Save that for last. Okay, number 8, that's the cube root. What's the +2 doing? And the -4? Okay. So take each of my points.
You in the middle of,
Yeah, I mean, if you need somebody.
well, we can wait till after class.
Okay, sorry.
If you get done early, Sydney, or sorry, Chevy.
Okay. So left 2, down 4. And so your graph should look like this. Is that alright? We're gonna wrap this up. We are going to skip the next section. I just wanna go to the very end and talk about those, and that's gonna be the last piece I look at today. So this is like that piece that you had on homework. And there's going to be another section like this on tonight's homework. You can do this a lot of different ways. You could sketch a graph, and then think about moving the point. You can try to write out your points and work from there. Graphing might be the easiest option if you're having trouble with it. So if I start with -2, 3, what would this -2 do? To the right 2. So if I took this point and moved it right 2, where is it at now? 0, 3. If you think about all the things I've been telling you about transformations, inside is x and it does the opposite. So this would be like adding 2 to your x. So it makes it a 0. So this one, a negative out in front, what does that do? Flips it over the x. So if you flip this over the x, where does it go? -2, -3. Or I've been telling you, outside is y. So if I have a negative on the outside, it's like putting a negative on my y. So -2, -3. Okay, this one, a 5. Outside is y. And it does what you think. So if I took this point, it would be saying, take your y times 3. So vertical stretch. So it becomes -2, 15. Just multiplying by that 5. Outside is y, does what it says. We look at this one. Inside is x, x does the opposite. So instead of multiplying my x by 3, I would outside is y, does what it says. So what does my point become? It's just taking your 3 times 1/4, so -2, 3/4. Okay? 18, you could think of it from the graph. If we want to keep doing what we're doing, we could think of it from the ordered pair. Outside is y, does what it says. So what's this telling me to do to my y? Right, so if you add 6 to your y, you get -2, 9. Okay, or you could just think if you wanted to graph it, take this point and move it up 6. Where does it end up? 19, inside is x, does the opposite. So you are going to take your x, which is -2, and divide that by 3/4. What does that give us? -8/3, and our y didn't change. 20, negative on the inside. So that's saying, if you want to think about your graph, the negative on the inside flips it over the y. So we would see it goes to +2, 3. If you wanted to work from your ordered pair, if you make your x a negative, if it's -2, the opposite of that becomes